So yesterday was a pretty long foundational lesson on finding sine, cosine, and tangent using the 6 trig functions in the unit circle. Today should be a little bit shorter, and we're going to take a different tact, but still be using this idea of finding these 6 trigonometric functions given some information. So we want to find cosecant and tangent if theta, which is an angle, is in standard position, and if the point -4, -7 is on the terminal ray of the angle. So what the heck does that mean? Well, if I set up a quadrant or coordinate axis and graph the point -4, -7, puts me somewhere down here, and it says that's on the terminal ray of an angle, like so. Right? And we want to know what's the secant, cosecant, tangent value. Well, basically what they're asking is what is the angle relative to that point made by the degree measure that's closest to the nearest x-axis. So they're telling us that we have a y value of -7 and an x value of -4. And they're asking for the angle relative to that ray closest to the x-axis. So in order to do this, we can't just go ahead and say, well, my r value in this case is 1 because it's no longer a unit circle. So we kind of have to take it off the unit circle. We have to, like we did earlier, use a Pythagorean theorem to calculate r. So I know that I have x squared plus y squared equals r squared. And we know we have -4 for our x, 7 for our y, that's negative. We're looking for our r value because we need to find cosecant. So this is not one of those special right triangles. It's also not a Pythagorean triple, so I got to go ahead and calculate all this. So this is 16, that's 49, which is equal to r squared. So I have a total of 65 for r squared, and r is equal to root 65. So again, we're looking for the cosecant, which is the reciprocal of sine, which is the opposite over the hypotenuse. So the cosecant, once again, is the hypotenuse over the opposite. And if you look in this case, the opposite to this angle is going to be -7. Hypotenuse is always going to be positive, so that's root 65. And there's my cosecant. To find tangent, all we're going to do is take the opposite over the adjacent. So tangent, we could have gone right from the beginning and found that. That's just -7 over -4. Thus we have 7/4. Now, in this problem it says my cosecant is 4/9, and we want to find the sine of that angle in the first quadrant. Well, again, here's the situation. It doesn't really tell us what my radius is. Now, you can assume that you're in a unit circle situation and this is just your x value, but I find it easier to just say, okay, well, what they're doing, since they're giving me a cosine, is they're giving me an opposite an adjacent and a hypotenuse ratio. So what I'm assuming is that they're giving me an adjacent value to an angle in the first quadrant, which means that's an x value of 4, and a hypotenuse value of 9. And then all I need to do is find my y value in order to get sine. So this is the way I prefer to do these problems. But like I said, if you want to call that x and call your hypotenuse 1 to make it a unit circle, go right ahead and do it. But I'm going to show you this way. So anyways, to find y, I take 4 squared plus y squared equals 9 squared. Get 16 plus y squared is equal to 81. I'm going to subtract 16 from both. And once again, get 65 is equal to y squared, so y is equal to root 65, first quadrant, so it's positive. I need the sign, which is the opposite over the hypotenuse. So in this case, the opposite is root 65, the hypotenuse is 9, and there's my sine value. Again, I have a couple of options. I know this is the tangent. I prefer to make this a ratio of my y over my x value, because that's the opposite and the adjacent. So if I know that and I want to find cosecant, I need the hypotenuse once again. So this is a third quadrant problem. So in the third quadrant, I'm saying my y value is 5, but what it has to actually be is -5. Since I'm in the third quadrant, my x value is 6, but it actually has to be -6. And the reason why tangent is represented as a positive is because I have two negatives in a fraction, which makes a positive. So anyways, let's go ahead and calculate. I have -6 squared plus -5 squared is equal to r squared. 36 plus 25 is equal to r squared. This gives me a total of 61 for r squared, thus r is root 61. Alright, and in that case, if I'm going to find cosecant, that's my r over my y value. So my radius is root 61. My y value in this case was -5, and there's my cosecant. And in this case, you'll notice that this problem, unlike the last couple, said we were in quadrant 3 here, said we were in quadrant 1 here. In the first problem, it basically gave us an exact point. But in this problem, they don't give us a quadrant. And I've got a little notation over here. There's actually going to be two solutions. We'll explain why in a second. So I know my secant value is 17 over 8. And again, I prefer to say, well, what ratio are they giving me? They're giving me a hypotenuse or a radius over an x value. So what I'm going to do is go ahead and calculate my y value, because I'm going to need y over x in the end here for tangent. And this is actually a special right triangle. I've got a hypotenuse of 17. I've got an x value of 8. All right, the x is going to have to be negative if this ratio is negative, because r is always positive. And there's an 8, 15, 17 special right triangle. So now, here's the reason I say there's two possible solutions here. Because what I have is I have a negative value for the x and a calculated value of 15 for my y. But does that guarantee that it's going to be positive? Let's take a peek. If x is negative, here's my -8. 15, think about when I do Pythagorean theorem. Let's just go through it real quick. I get 17 squared minus -8 squared equals y squared. When I take the square root of both sides, I could get a positive or negative value for a y. In some of the other problems we've done, we've been looking for a radius, and when you can't have a positive or negative value. But the y could certainly be either positive or negative. So look, I could have this angle right here, or I could have this angle right here, both giving me a value of 15. One would be positive though, and one would be negative. So there's actually two answers in this case. If we want to find the tangent, we either have a 15 over -8 or 15 over 8. This would be the third quadrant. This would be the second quadrant answer, because in this case the y would be positive, in this case the y would be negative, thus two negatives make a positive. Alright, so now we're going to use a calculator to do some of the following calculations. Now, one of the most important things to pay attention to is whether you're in degrees or radians, because that means you have to set up the mode in your calculator differently. In this first problem, we're in degrees, so I'm going to go to mode, and I'm going to look, and in this third line, you'll notice that degree is highlighted, so I'm already in degree. Now, if you clear your calculator will default to radian, and this is why I say check every time, because you don't want to do a test and find out that you're in radians when you should be in degrees at the end of the test after you turned it in, because all your answers will be wrong. So I'm in degrees. I get out of this window, and I just hit the sign of 72, hit enter, and it'll give me an approximation. So I've got, what, 0.95 as my solution for the sine of 72. Now, when I go to 20 degrees, you'll notice I'm trying to find a secant. Well, there are no secants. It's just sine, cosine, and tangent. And these little blue notations right here of -1, these are the inverses. They aren't the reciprocals of cosine. The reciprocal of tangent, or the reciprocal of sine, those are the inverses. And we'll talk about how we use those shortly. But if I want to find the secant of something, I have to take the reciprocal of the cosine. Remember, secant is the reciprocal of cosine. So if I take 1 over the cosine of 20, I'm going to be able to find this value. So I'll go to my calculator, hit the cosine of 20, like so, and then go 1 divided by that answer. And hitting the divided sign would be good. And we end up with 1.06. Like so. Now, you'll notice this next problem is in radian. So we're going to have to go back to our calculator, hit mode, move down to radian, hit enter. Now you'll notice the radian's highlighted. Quit that, and then we're going to type in the tangent. I always, on my fractions, put numerators in parentheses, so I'll open another set of parentheses and go 3 pi. Pi is second and the caret sign. Close my parentheses and hit divided by 8. Close the parentheses again, hit enter, and end up with 2.41. Like I said, a little bit shorter today. Took a different angle on how we were calculating these things. Do your Mind Math Lab. We'll talk about it tomorrow.